Hi everybody, my name is Ognjen Todic, and today I'll talk about voice-enabling mobile apps and custom hardware devices. Thank you for attending this talk. Just to give you a brief overview, I'll cover a little bit of a background of myself and the company I work for. Then I'll talk about some interesting use cases, real-life use cases. And then we'll dive a little bit deeper into kind of voice technologies, give you an overview of different subsystems that are relevant, explain how voice assistants work at a very high level, kind of 101. And then we'll talk a little bit about evaluation, what kind of things you want to look at, how to approach that if you're thinking about voice enabling your mobile app. And I'll follow up with various tips, somewhat random but relevant that we see basically in our experience when working with companies that are voice enabling their mobile apps. And hopefully we'll have a little bit of time for questions at the end. So brief background, as I said, Ognjen Todic, I go by Ogi, much easier, my first name. I'm the CEO/CTO of Keen Research. This is my email. Feel free to follow up via email if you have any questions after this talk. Keen Research is the company. We're distributed. We're a small bootstrap tech company based here in the Bay Area in Marin. But the team is fully distributed. So, I'm here. There's somebody in Vancouver, Poland, Scotland, Serbia, kind of everywhere. And what we do is we develop and license SDKs for on-device speech recognition on mobile devices. Our SDK runs on iOS, Android, Linux. We have Unity plugin. We provide models that work well for adults, but also for kids. And we have a booth on the second floor in the other part of the building. So come talk to us after this presentation if you're interested in learning more. Just kind of a little bit of bragging. We have bunch of different customers, but mainly kind of ed tech is one big space. And the reason I'm really bringing this up is to help you understand that, and I'll talk more about this, what are the different use cases where speech is actually useful and relevant, but maybe not the voice assistant type scenarios. So ed tech, educational technologies, where we have a lot of customers, Viacom, Nickelodeon, Voice Powers, RSDK Voice Powers, their Noggin app, PBS Kids, Novel Effect, which I'll talk more about, several apps helping kids learn how to read. Then on the enterprise side, a lot of stuff related to augmented intelligence for frontline workers. So basically helping people that are maybe wearing gloves or have greasy hands, they need some information or they need to input some information. And all of that is not that far. It's in their pocket, but it's actually hard to use it because of the environment they're in. So they can do it by voice, basically. And then a bunch of one-offs, and I'll cover, again, a few of these. One of them is the voice-controlled metronome. Another one is MiraCheck, an app for sports pilots, virtual assistant for sports pilots. And then, again, a few other ones that I'm not going to go into too many details right now. So I'm sure all of you know about Siri, Alexa, Google Home, or Now, whatever it's called these days, their assistant. These general-purpose virtual assistants are around us, have been for about 10 years now. And everybody, or most people, I should say, use them. Pretty much everybody knows about them. One of the main takeaways I'd like you to kind of take home from this presentation is that voice interface is not only about general purpose voice assistants. A lot of people think about Siri, think about Alexa when somebody mentions voice, but there's a lot more to it. And so to illustrate that, I'll give you a few examples, few real-life use cases, and these are all our customers. These are all apps that you can download. Some of them, I believe, are free or freemium. Some of them require subscription. But I'll show some videos to give you an idea how voice can be used that's not directly, for the most part, like typical virtual assistant use case. So I'll start with Hey Metronome, which is voice-controlled metronome. For those of you who are not familiar with metronome is. It's a device. It used to be a device, mechanical device that makes beat. So musicians use it when they practice to stay on track, because you're supposed to play with a certain beat. So it's like it goes tick, 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 and you can change the frequency of the metronome. In the last, I don't know, since smartphones, there's a lot of digital metronomes. So it's basically a mobile app. And people at AudioKit, which is an open source iOS only project for audio, they built this voice control metronome. So I'm going to show you a video of how this works.
Hey metronome, set tempo to 100 beats per minute. You got the groove.
So that's one example, and then...
Hey metronome, moderato. Hey metronome, allegro. Hey Metronome is a really great app. It's got a lot of features and users use voice to interact with it. What I find it really helpful to me is that when I practice, I tell what to do with my voice instead of fingers, and it makes the practice more effective.
So what's interesting here, I was telling you about frontline workers, but this is a similar scenario. It's like this musician is holding the violin in his hands, and in order to change the beat on physical metronome or mechanical one or an app, he would need to put down the violin, do something, pick up the violin, and to continue playing. And this way, it's very smooth. He just says what he wants, and it happens. This is a super cool app. It's called Novel Effect, and what it does, it is augmented audio reality for storytelling. So parents are reading to their kids a book, typically a real book, and this is for toddlers, younger kids. And the app is following, it's recognizing what's being said, and it plays audio effects that correspond to what's in the book, what's being said. So it makes this kind of immersive setting where it pulls kids into understanding the story, pulls kids into the story basically a lot more. Let's hear some examples.
Who's excited for stories? Let's raise our hands.
This pre-K class at Our Beginning Childcare can be wiggly.
We'll just pick the Polar Express and we'll hit read book.
But on this day,
on Christmas Eve, many years ago,
everyone is at full attention.
The Polar Express let out a loud blast from its whistle and sped away.
Storytime becomes an immersive sound experience with a Seattle-based app called Novel Effect.
It's so cool to see kids just 100% focused on a book reading experience as if they're watching a movie. Wolfie slept through the night.
As Matt reads, voice recognition follows along in the app, synchronizing sound effects and theme music.
So anyway, what's really cool with this product, with this app, is that there's no, when the users are experiencing, there's no phone, there's no app, like it's hidden. Like the focus is on the book and interaction around the book, and the phone is just a speaker. And kids don't necessarily even know that the microphone is on, right? Another cool example is Mira Check. It's a sports pilot's virtual assistant. And let's see.
Are you ready to start? I am listening.
Check.
Call for fuel.
I got fuel this morning already? Check.
Stall horn, test.
Check.
Lights, internal and external.
That's Jeff.
So what Jeff, who is the CEO of this company, is doing here, he's basically a sports pilot. There's pre-flight, post-flight checklist that you need to do, and it's kind of critical for safety. And if you don't do it, you can get in trouble. So a lot of early on, it was all paper and pencil. Then somebody built an app, digitized it. But what he did is basically he voice-enabled it. So he's just walking around with his hands in his pocket. He has a headset. I don't know if that was obvious. And the app is telling him what to do. Check the fuel, check this, check that. So there's a long checklist, there's a long procedure that needs to be completed. And then beyond that, once you're in the cockpit, once you're flying, it becomes actually a virtual assistant. You can ask it for weather at your destination, different types of information that are relevant for somebody who's flying a plane, basically. All right, so those are a few examples of voice experiences that are, maybe the last one is some sort of a virtual assistant, the other two, not really. I'm going to cover, like, at a high level, how these assistants work. And not all of these blocks are required for all the use cases. So this is kind of the most generic, I would say, description. So if you look from top left, you go around to the bottom left, from the microphone to the speaker. Basically, the audio is captured through the microphone. Sometimes there's more than one mic. And so you have a digital audio, and then sometimes, not always, there can be a wake word. And we'll talk more about what that is. But that's basically, hey Siri, hey Alexa, that wakes up the system, the full system, right? From there, the audio keeps going through automatic speech recognition, which basically takes the digital audio, which has presumably some speech, and turns it into ASR result, which is the most relevant part of it is text, of what is being said. But there's other things, and we'll talk more about that. And then from there, you take that text, and it goes through natural language understanding module, which basically extracts meaning. So what does the user want, right? So typically, this comes down to intents and values, and we'll talk more about that. And there's some sort of then knowledge management system. Okay, we know what the person wants. Let's grab relevant information from somewhere. And these two are usually working in conjunction. There's dialogue management. Then you're figuring out, okay, I need to actually tell this to the user now. What is it that they wanted? Give them back information. So you create first the text of that, and then you use text-to-speech module to create speech, synthesize speech from that text. So this is a high-level overview. I'll go into these components now separately. So we'll cover wake word, ASR, TTS, NLU, and acoustic echo cancellation. Wake word I already mentioned. All of you, I'm sure, are familiar with this. Hey Siri, hey Alexa. This is typically a very small neural network model or cascade of models that's trained for a specific phrase. Cascade, typically there's two stages. One is somebody talking at all? That would be the first one, super lightweight. And then the second one that's also lightweight, but maybe a little bit more complex, which is, oh, somebody's talking. Now I'm trying to figure out, are they talking to me? Is there a wake word there, right? So that would be the cascade. In all the virtual assistants that are general purpose, on the mobile phones especially, these are meant to run 24/7. So they need to be super lightweight in terms of CPU utilization, battery, memory. Battery is the most important one for 24/7, but also they run all the time, and other apps need CPU and memory, so they can't really, this part cannot really overtake a lot of resources. Usually these models are trained for a specific phrase, and this involves custom training. Now, why do you need wake word? When these are they're called smartphones, and they are smart in a lot of ways, but then they're kind of dumb in some other ways. So when we talk as humans, we're pretty good at figuring out, is that person that, if it's a group setting, are they talking to me or somebody else, right? There's a lot of cues that we take that are not just speech that we're hearing. But one obvious one is somebody says, hey, Yogi, I know that they're talking to me, right? So this is the main thing here, is like the app knows that the user is talking to it, not to somebody else. And based on that, it could be also, there's two pieces here. One is it talking to me? If it's not talking to me, I don't want to get confused with what they're saying. And the other piece is if it's not talking to me, I don't need to actually use the resources. If they're locally running, then I don't need to use CPU, battery, etc. for speech recognition, NLU, and all of that. Or in the case of the cloud, which up until recently, a lot of this was being streamed to the cloud, that's when you tie up the resource in the cloud and you say, okay, I'm going to start actually streaming to the cloud. Otherwise, you would have to have something in the cloud that's tied to every mobile phone. That's not scalable, right? You can't, the beauty of the cloud is you can share the resources, but if everybody's using it all the time, then it's really problematic, right? But there are also scenarios where you don't need a wake word. So in situations where the user is not going to be in the setting where they might be talking to somebody else or somebody else talking to them, you don't need to, whenever somebody talks, you know they're talking to the app, right? And also, if it doesn't need to run 24/7, that's another example where you can actually then go without the wake word. So one example is some of our customers use for this augmented intelligence, they use our solution in their mobile apps that are run, that warehouse users use. So workers in the warehouse walk around, they do different tasks. They're not talking to anybody. They're on a forklift driving around. When they're talking to the device. And they do it for a shift, 7-8 hours, and that's it. So, and the other problem with wake word in this type of setting is they're using this very frequently. So if every minute you have to say, hey, device, do something. Hey, device, do something. It kind of gets in the way. It becomes cumbersome. So that's kind of the wake word. So once you can use the wake word, you don't have to. There's scenarios where you can just tap and to start listening, for the app to start listening. That would be alternative. It goes to speech recognition. You'll hear words or terms like ASR, that's just the acronym. Speech to text is also commonly used, STT, voice recognition, all these things, all this are the same, they mean the same thing. I'm not too fond of speech to text because there's a lot more in the result than just the text. But basically, you have as an input, you have an audio, digital audio, that presumably contains some speech, and output is text, and usually with some additional metadata. What that metadata can be, you can get confidence scores for each word, you can get timings for words, you can get timings even for phonemes, individual sounds. A lot of our customers use SDKs for language learning and helping kids learn how to read. So we have something that's called goodness of pronunciation. When you set the word, how close it is to the native speaker, that will be also some metadata about the result. You can get pitch, signal level, signal to noise ratio. So a lot of additional information can be in this result. These systems can be cloud-based. Or they can run on device. So when you have something in the cloud, a big advantage of the cloud approach is that there's two of them. One is what I've specified here, is that you can run larger models. There's effectively, there's no limit on memory and CPU on the cloud. It's probably like 2 orders of magnitude larger than what you can get on the mobile device. And the other one is that it's very easy to update the models or software, right? You just switch it on the server and it just works. There's no need to do anything else. On device, on the other hand, everything runs locally, so you don't need to stream audio to the server. It's processed locally. So for a number of use cases where privacy is relevant, or security is relevant, you're in some enterprise setting or law enforcement, right? You don't want to stream this somewhere else when somebody could potentially listen to it. That's a big advantage. Low latency, so there's no round trip to the server and back. Obviously, you don't need internet connectivity if it runs on device. You don't need to scale the infrastructure on the back end. And this is kind of related to the infrastructure, but it's definitely more cost effective at scale. Another interesting thing for speech recognition and other blocks in that diagram or subsystems is the domain. So if you think about those examples that I've shown you, hey, metronome, novel effect, mirror check, all of them are working in a narrow domain. And those domains are different, right? Metronome, recognizing numbers from, I don't know, 50 to 200, and maybe like 50 or 100 words that are, musically related, from music domain. Novel effect, you tell the app what book you're reading, right? So the domain is all the words in that book. Mirror check, again, avionics, vocabulary, fairly small, maybe a few hundred words, right? When you think about cloud-based solutions, pretty much all of them are solving what's called like large vocabulary dictation problem. And that's really, I don't care what you're saying, whatever you're saying, I'm gonna recognize, right? So it's kind of like dictation. You don't know what you might be saying, or what the user might be saying. And that works pretty well for typical speech. If you're, texting your friend or doing something, I don't know, I always use it in my car. I use Siri, and it just works well. But when you start using some jargon, technical terms, and stuff like that, then you start hitting the problems. You get something that sounds like what you're saying, but it's not what you're saying, right? There's this famous example in speech recognition world, recognize speech and wreck a nice beach. Those two, when you say them quickly, they sound very, very similar acoustically, but they have totally different meaning. So if you think about the domain, you can have something on one end of the spectrum is like large vocabulary recognition. On the other one is command and control, maybe 10 words or 50 words or something like that. And there's a lot in between. And you don't necessarily need large vocabulary dictation systems for this stuff that's in between. All right, we'll quickly go over the text-to-speech. Very obvious name, right? So what it does, it converts text. Input is text, output is speech. It can also run on device or in the cloud. Important attribute is quality. So you probably, if you've used Siri from the get-go, it was a lot more robotic back then, and some systems before, 20 years ago were like very robotic when you hear this kind of TTS voice. So quality, how close it is to natural human speech. The other piece is prosody. So if the text has a question mark in the end, is it going to actually set the pitch properly so that it sounds, there's inflection there, so it sounds like you're asking a question, it's not a neutral statement. All these things make speech sound more natural, basically. From the development point of view, what's important is how long does it take to create it, right? So if you remember, if you go back to that block diagram, user said something, there was wake word, there was speech recognition, all of these systems include some delay, there was a lookup of the result, now we have a text, we know how to respond to them. How long is it going to take to create that speech that we're going to play to them? If it's a few words, that may be 3 seconds worth of audio. Can the system start getting back audio to us before it completes the full thing? Because then we can start streaming early on. And if it cannot do that, then what's the real-time factor? If it's 0.5 for 3 seconds of audio, that would mean it takes 1.5 seconds to create that audio file that we're going to play. And 1.5 seconds is pretty long delay. So when you think about latency, when I ask for something, if I have to wait maybe half a second for other pieces and then 1.5 seconds to this, user perception of the latency may not be that great, basically. So those are the things to think about when you think about text-to-speech. Now, this is also important. You don't have to always use text-to-speech. So if you're responding, for example, metronome is responding actually by text. It just shows the text. What it does some action, right? It's going to change the beat. So it's very obvious to the user, hey, it heard me, right? And it's only if something is off, it may be misrecognized, you might take a look at the screen and say, oh, it said 139 or instead of 135, right? So you don't have to use speech as an output. And if you use speech as an output, if it's very constrained and small, you can just pre-record audio and play audio of a human that actually said those things ahead of time. That approach doesn't scale. If you have a lot of things that that your system can say back to the user, that's not going to work well. But if you don't, there's no reason to use TTS. All right, so switching to natural language understanding. What NLU, what it does, it extracts meaning from the text. So typically, we talk about intents and slots and values when we talk about NLU systems. There are more advanced approaches these days, but if you think about metronome example, when we say, hey, metronome, set beat to 120 beats per minute, set beat would basically is an intent. The user wants us to change the beat, and it should be 120. The value is 120 for BPM slot, and then the app can do something about that, right? Or if user says, hey, metronome, next song, and for the context, metronome has the concept of playlist, so it would be next song in the playlist that you're practicing, then there's just intent to switch to the next song. There's no need for any slot or value for that specific intent. Now, if you remember on that block diagram, there was dialogue management. Where that comes into play is for multi-turn interaction. So if you say, hey, metronome, set beat, the system should be smart enough to say, okay, the intent is to set the beat, but I don't have any value. So then the dialogue management would be smart enough to say, what do you want me to set it to, right? So now you're it spans multiple responses. In one you capture the intent, in the second one you capture the value and the slot to set the beat properly. The NLU systems typically require labeled data to train the model. And label is basically, data is text, and label is exactly what's kind of colored in these examples here. And then sometimes there are systems that have fused ASR and NLU models, so it's kind of like speech to meaning, or fused even ASR and NLU and dialogue. But a lot of these very advanced. I'm not quite sure how much of it is used in kind of production system these days. A lot of research around this, though. Acoustic echo cancellation. So novel effect is a good example. The app is playing effects all the time. So what happens is, if you think about it, the speaker on that phone is playing audio all the time, and the microphone is listening all the time to figure out what the user is saying, what the parent is reading, right? So everything that's coming out of the speaker gets captured by the microphone. And guess what? On these smartphones and tablets, guess where the speaker is in relation to microphone? It's right next to it. So basically, this signal can really saturate the microphone and create problems, and it's hard to even hear the speech in the context of that signal. Luckily, there are ways to deal with this, and this is what acoustic echo cancellation is. So because the system is playing the audio, it knows what it is. And basically what this AEC module does is it takes out the audio from the input, from the microphone that's being played. So you get clean speech on the output of the AEC module. All right. Something else that's important is, where is the device, or microphone, I should say. So there's this concept of far field speech and near field speech. A lot of far field would be anything that's more than like your arm reach away, so 3 feet or so, roughly. And when the microphone is farther than a couple of feet away from the speaker, there's a lot of degradation that happens because of attenuation, because of reverberation, a lot of effects that basically, if I'm talking and that's, speaker over there is where the mics are, it's going to be really hard for a speech recognition system to actually recognize that audio because it's going to be degraded significantly. But there are ways to deal with this, and the ways that Alexa, all these like home virtual assistants that are devices deal with this, because you can talk to them across the room, is there's more than one microphone. So there's what's called a microphone array, 2, 4, 8 microphones, and something that's called beamforming, where you can get rid of a lot of attenuation and reverberation, basically, because you have multiple microphones. So if you're interested in building an experience, voice-based experience, what are the questions you should think about? How should you approach this? The first question we ask anybody who comes talk to us is, like, what's the problem you're trying to solve? But what this translates to is, what is the task? Are you dictating notes or messages? Is it command and control? Are you enabling some sort of special experience? Is audio going to play while speech recognition is listening? Then you need this acoustic cancellation. How is it used? Do you tap a button to talk? Is there a wake word? Is it always on listening? All these things are relevant to figure out what's the proper solution. Who's your user? Kids, elderly, trained users in the enterprise, non-native speakers. All these things are going to affect performance or should affect your decision on what solution you're choosing. I already covered a little bit about on-device versus cloud. And I'm mainly focusing here on speech recognition, by the way. But there's third-party solutions like ours. There's some open source solutions. There's platform solutions on some platforms. And maybe you're big enough and this is strategic to you and you want to build it in-house, right? So these are big decisions to make. If you're running on device, which is relevant for us, what kind of device is it? Can it run in real time? How far, and if you're talking about mobile apps, it's basically how far back do you need to go? What's your user base? To give you an idea, I mentioned a lot of our customers are in ed tech. What happens in ed tech is kids are users, and there's lots of tablets, which are generally speaking always like one generation behind in terms of capabilities from the smartphones. And then there are lots of hand-me-down devices. So a lot of our customers, and this is a little bit easier on iOS to kind of quantify, but a lot of our customers run iOS 11, whereas iOS is at 15 now. I think next week it's going to be 16. If you have an app that's out there already, you can tell what the device distribution looks like. If you're building custom hardware, all of the previous things are important, but what's really important if you're building custom hardware is how you're building audio capture. Because if you're not capturing audio properly, all the downstream tasks are going to be affected and they're not going to work well. When we talk about evaluation, again, focusing on speech recognition mainly, what we always recommend is if there's an authentic test set, which means audio files and transcripts of what was being said. And then you can use this test set to test any solution you're looking at in an objective way. You measure what's called the word error rate, and you measure it on the same data, and solution A gives you this, solution B gives you this, solution C gives you this. And then you can take a look at, figure out, which of those are above certain threshold that's relevant for you, and then look at other factors as well. The other thing is, don't get blocked on creating a perfect test set. People are like, okay, we need to spend 6 months to create a perfect test set. No, create a small one, start with something, and then you can evolve it over time. The most important thing is, whatever you use, understand how close that is to what your real use case scenario is, and don't overgeneralize the results from the performance on that test set. You can also use proxy test sets. There's lots of free data sets with speech available these days, or rely on some performance reports that vendors provide, as long as you understand what data they used and how that compares to your use case and scenario. Some quick tips. Think about who your users are. It's different if it's consumer product versus B2B. B2B users you can train, etc. Are they motivated to use the app or this new feature? In big institutions and corporations, sometimes interests are not always aligned. Management wants better productivity, etc., and end users, they don't want change. So now they need to use voice. They're like, oh, I don't know, I'm not too crazy about this, even though it's going to help them too. In terms of user interface, make it obvious to users when it's their turn to talk. You can use visuals for that. You can use audio, beeps, think about, how Siri works. I think it's a pretty good example. also reduce cognitive load on the user. If you ask for confirmation, sure should be accepted in addition to yes, no, yeah, nope. Especially if you're dealing with, if it's a consumer app, right? I think actually I'm gonna skip this slide, and then I think tuning is also relevant, capture enough information during testing before you launch. Again, we're on the second floor booth, come talk to us.